Hello class, a very warm welcome in today's session. In today's session, we are going to continue our third lecture of the chapter that was motion. In the previous lecture, we have studied about uniform and non-uniform motion as well as about speed, distance, displacement, and also we have studied the concepts of uniform speed and non-uniform speed and average speed. And in today's session, we are going to continue with the concept that is velocity. So what is velocity? The distance traveled by an object in unit time and in a given direction. See, in the case of speed, we have studied that the distance traveled in per unit time is known as speed, but in the case of velocity, it is distance traveled per unit time taken in a particular direction. So that will be a velocity. It can also be defined as the displacement of a body in unit time, because we are taking the distance traveled per unit time in a given direction. So we can also write it as the displacement covered in a unit time. Okay, because the distance traveled in a direction is the displacement covered in a unit time will be the velocity. So what will be the formula according to the definition? Velocity is equals to displacement upon time. Velocity is a vector quantity, and why we are saying so? Because it needs the direction as well as the magnitude. Its SI unit is same as that of speed, obviously, because displacement upon time will be the formula. So for displacement it is meter and for time it is second. So meter per second will be the SI unit, but in case of larger objects it is kilometer per hour. Okay, I hope this is clear to you. Now moving ahead, you can see here that we have the next topic, that is uniform velocity. So what will be uniform velocity? If an object covers equal distances in equal intervals of time in a given direction, it is said to have a uniform velocity. It is so easy because we have studied already the uniform motion as well as the concept of uniform speed. In that case, we have studied that if an object covers equal distances in equal intervals of time, that is a uniform motion. So if I am talking about uniform velocity, so it becomes if an object covers equal intervals, like equal distances and equal intervals of time in a particular direction, that will be the velocity. So we are adding the direction because of the vector quantity of velocity, right? So for example, if an object moves a distance of 1 meter every second in the same direction, it is said to have a uniform velocity 1 meter per second. Like if an object is covering 1 meter in every second in a particular same direction, so that will be the velocity of that object. Okay, uniform velocity basically. Now moving ahead, we have the next topic, that is non-uniform velocity. So this will be the opposite of uniform velocity. An object is said to have a non-uniform or a variable velocity if it covers unequal distances and equal intervals of time in a given direction. So whenever any object is covering unequal distances in equal intervals of time in a given direction, that will be the non-uniform velocity or a variable velocity. For example, if a car moves 70 km north in the first hour and of its journey, 45 km north in the second hour and 56 km north in the third hour, then it is said to have a non-uniform velocity. As you can see clearly that it is covering unequal distances in equal intervals of time in a given direction. So that's why it will have a non-uniform velocity. The second thing, like when an object is covering equal distances in equal intervals of time, but its direction is keeps on changing, right? So that's also a non-uniform velocity. Okay, so whenever any object is covering unequal distances in equal interval of time in a given direction, that will be a non-uniform velocity. But if an object is covering equal distances in equal interval of time and constantly changing its direction, the motion of the direction of the motion, so that will be a non-uniform velocity. Okay, for example, if a car moves 70 km north in the first hour of its journey, 70 km west in the second hour and 70 km northwest in the third hour, it is said to have a non-uniform velocity. As you can see clearly, the object is constantly changing its direction of during the motion, so that's why it will have a non-uniform velocity. Now moving ahead, we have the next concept, that is the differences between speed and velocity. See, what we have studied previously, that what is speed? Speed is the distance traveled per unit time taken. The SI unit of speed was what? It was meter per second, and the formula is speed is equals to distance traveled upon time taken. But in the case of velocity is what? Velocity is distance traveled per unit time taken in a given direction. So that will be the velocity of an object. So that's why the formula becomes velocity is equals to displacement upon time taken. Why I am taking displacement? Because I have taken the definition as distance traveled in a given direction, and distance traveled in a given direction is displacement. So the formula becomes velocity is equals to displacement upon time taken. The SI unit will be the same as of the speed, that is meter per second, and for the bigger vehicle vehicles, it is kilometer per hour. It is a vector quantity because we are using the direction. So that is what the difference between the speed and velocity. You can see here the speed of a body is the distance traveled by it per unit time taken. The velocity of a body is the distance traveled by it per unit time in a given direction. In the case of speed, it is a scalar quantity, and in case of velocity, it is a vector quantity. Speed tells us how fast an object moves, obviously, but velocity tells us how fast and in what direction an object moves, because it's a vector quantity, and that's why it is using the direction as well. I hope the point is clear to you that what is the difference between speed and velocity. Now, moving ahead, you can see here that we have the next topic, that is mass. Now you are wondering that what is mass? Let me just clear it out. The mass of a body is defined as the amount of matter contained in it. So this is very important. Why? Because a mass and weight, there are two terms, mass and weight. So a lot of students get confused about these both topics, right? So mass is what? Mass is the matter contained, the whole amount of matter that is contained by a object, right? So the mass of a body is a constant quantity. It does not change with change of place or direction or application of force. Obviously, it is a constant quantity because obviously the matter that an object is containing, that will be the same throughout the universe. In every direction, in every condition, that will be same, right? So that's why mass is constant, right? SI unit of mass is kilogram. To commonly use some multiples of kilogram, kg are gram and milligram. Like these are two commonly used sub multiples in, like we can say that 1 kilo, you know very well that 1 kilogram is equals to 1000 gram, you know that, right? So this will be the two commonly used multiples. Now you can see here that we have the measurement of mass. Now how we are going to measure the mass of a particular object, that is very important. Okay, so the mass of a body can be measured by comparing it with a standard non-mass. Like when we are comparing it with a standard non-mass, then we can easily calculate or easily measure the mass of the object. The simplest instrument used for this purpose is a beam balance. So beam balance is an instrument which is used to measure the mass of a particular object, right? A modified version of the beam balance is physical balance, is also used for measurement of mass. Beam balance, like physical balance is the modified version of beam balance. You will be given the image of these both in the next slide. It is mainly used for scientific purposes and by jewelers. So physical balance is basically used by jewelers as well as in the scientific purposes for those measurements where high accuracy is needed. Nowadays electronic weighing machines, and in current scenario electronic weighing machines are there which can be like which can measure accurate mass of a particular object, okay, are also used for measurement of mass. So on the other screen you can see here that we have the images of beam balance, physical balance and electronic weighing machine. So these three instruments are basically used for the measurement of the mass of a particular object. Okay, I hope this is clear to you. Now moving ahead, we have the next topic, that is weight. Now you will be wondering that what is weight? We know that all objects fall downwards when left free or unsupported. We know that very well. If I am just dropping it free, so what will happen? It will go down under the gravitational force, right? So it happens due to the force of pull or gravity exerted by the earth. The weight of an object is the force with which it is attracted by the earth towards its center. So what is weight? It is the force with which it is attracted by the earth because of its own weight, right? As the force of gravity changes from place to place, the weight of the body also changes from place to place. Obviously weight is dependent on the gravity, but mass was not dependent on anything. Mass will be constant, right? So weight is dependent on gravity. Wherever the gravity is changing, weight will be changed, right? You can see here that the units of weight, well, what will be the units of weight? Because we are saying that weight is a force, is a kind of force, and that's why the unit will be Newton. The SI unit of weight is also Newton, right? Weight is also expressed in kilogram force. We also discussed it in kilogram force. Okay, the SI unit will be in kilogram force and gram force. Now what is kilogram and gram force? 1 kilogram force is defined as the force with which the earth attracts a body of mass 1 kg towards its center. So whenever a body of mass 1 kg is attracted towards the earth by its weight of 1 kg, so that will be 1 kgf force. But similarly 1 gram force is defined as the force with which the earth attracts a body of mass 1 gram towards its center. 1 kgf will be equals to what? 9.8 Newton. This is a very important expression. So 1 kgf will be 9.8 Newton. That will be 10 Newton approximately. Okay. I hope this is clear to you. You can take the screenshot of this. Now, moving ahead, you can see here that we have the next topic, that is measurement of weight. As we have studied the measurement of mass, like there were different instruments from which we can measure the mass of an object. So exactly in the same case of weight, we have an instrument which is this, that is the spring balance. So it will be applicable for the measurement of weight of an object. How? The device used to measure weight is called a spring balance. As the name suggests, the device consists of a spring. Obviously, if we are calling it as a spring balance, so it will have a spring whose upper end is fixed at a point, like this will be the upper end and that will be fixed, that will be pivoted. Okay, and the lower end is attached to a hook like this. Here you can see here, okay, used to hang the object whose weight is to be measured. Now here in the hook you will just hang the object whose weight to be measured. Okay, the spring has a pointer attached to it. This will be the pointer over there, like this will be the pointer. So what will happen, and there is a scale over there. There is a scale always. Okay, so and the whole system is enclosed in a metal case. The front side of the metal case has a vertical slit and is marked with a scale. You can see here the figure over there. Okay, this will be the hook, this will be the fixed point, this is the scale over there, and this whole is under a plastic cover, or we can say metal cover. Okay, in this there is a point which will be going up and down according to the object's weight. Okay, now moving ahead, what you can see here, a spring balance works on the principle that when an object or load is suspended from the lower end of a spring, like whenever any object is suspended here at the hook, so it will just pull down, the spring, and you can easily find out the weight of the object, okay, with the help of this scale. Okay, so you can see that end of a spring, the spring gets stretched. Greater the load, more is the stretching. So whenever the load will be greater, the weight will be greater, so greater will be the stretching. Obviously, you can take the screenshot of this. Now moving ahead, we have the differences between mass and weight. What is the difference? Basic difference between mass and weight. The first point says about the mass, the amount of matter contained in a body is called its mass. We have studied that the matter that is contained in a body is the mass of the body. But in case of weight, the weight of a body is the force with which it is attracted by the earth towards its center. Right? Next point says the mass of a body is constant and does not change with place and position of the body. Obviously, it is not going to change because it is the matter contained in that particular object or a body. Right? But in case of weight, the weight of a body depends on the force of gravity and thus changes from place to place. It is going to change from place to place because it is dependent on the gravity of the earth, right? The mass of a body can never be zero, obviously, but in case of weight, it can be zero where the gravity is zero, right? So the weight of a body can be zero if no force of gravity acts on the body. The SI unit of mass is kilogram and the SI unit of weight is Newton, right? The next point says the mass of a body is measured by a simple beam balance or a physical balance, but in case of weight, we use spring balance to measure the weight of the body. The weight of a body is measured by a spring balance. Now, moving ahead, you can see, you can take the screenshot firstly. This is a very important table about the difference between mass and weight. Now, moving ahead, we have a concept map, like this one is the first one and this one is the second one. The very first one, concept map, is about the types of the motion that we have studied in the lecture 1 of this chapter. Okay, you can see that types of motion. The very first is rotatory motion over there. You can see motion of an object about a fixed axis, that is the rotatory motion. Okay, when motion through same distance and same duration, that will be the translatory motion, and translatory motion is of two types, that is rectilinear and curvilinear. Rectilinear will be motion in a straight line path, like if an object is covering the motion in a straight line path, that object will have a rectilinear motion. But if it is covering motion in a curved path, so that will have a curvilinear motion. And curvilinear motion's special case is circular motion, which is motion around a fixed point in a circular path, right? So this was translatory, this was rotatory. Next one, you can see motion with no specific path, that is a random motion. Like if a mosquito is randomly moving here and there, so that will be a random motion. Next one is more than one type of motion at same time, that's a combination, right? That's a combination of different motions, and that's why that will be a combination of multiple motion. Now, motion that repeats itself after regular intervals of time, like if any object is repeating its motion after regular interval of time, that will be a periodic motion. We have studied about this. And again, if an object is not covering, not repeating, that will be a non-periodic motion. Okay, whole body moves to and fro about a mean position, that motion was oscillatory motion. And oscillatory motion's special case was vibratory motion, when some parts of the body move to and fro about their mean position. Okay, so this was all about the types of motion. You can take the screenshot of this concept map because this is very important. Now moving ahead, we have the next concept map that we have studied in again the two lectures, that is about speed and velocity. You can see here that motion is described as change in position firstly, right? So change in position can be of distance and of displacement, right? Distance is the actual length covered. We have studied what is distance. Distance is the actual path or actual length covered by an object from the initial to the final position, and it is a scalar quantity. Why? Because a quantity that can be described only by magnitude is a scalar quantity, and distance is obviously is going to be denoted by its magnitude, and that's why it's a scalar quantity. Now distance covered per unit time is speed. Okay, and speed is also a scalar quantity. Why? Because we are denoting the speed with the magnitude only. Okay, now what will be the SI unit of speed? That will be meter per second. We know that very well, because speed is equals to distance upon time. The SI unit of distance is meter, SI unit of time is second, so it becomes meter per second, right? The speed can be uniform and non-uniform. Now what is uniform and non-uniform speed? When an object is covering equal distance in equal interval of time, that will be the uniform speed, and when the same object is covering unequal distance in equal interval of time, that will be the non-uniform speed. So that is what is written here. When a body covers equal distances in equal interval of time, that is uniform, and when a body covers unequal distances in equal time intervals, that is non-uniform. Okay, I hope this is clear. Now next one is the displacement. What was displacement? The shortest distance between the initial to final position, that will be the displacement. Okay, so you can see displacement is a vector quantity. Now why I am saying that displacement is a vector quantity? Firstly, you have to understand that what is a vector quantity. I have told you, vector quantity is a quantity where we are using the magnitude as well as the direction of that object. Okay, so why I am saying that displacement is a vector quantity? Because we are denoting the displacement of an object with the magnitude and direction. Right, so you can see a quantity that needs both magnitude and direction to be described is a vector quantity. Okay, displacement made per unit time is what? It is velocity. Why? Velocity is equals to displacement upon time taken, right? So the SI unit of velocity will be meter per second, again in a particular direction. So SI unit will be meter per second, and velocity is also a vector quantity because we are using the direction in this case as well. Okay, velocity can be uniform and non-uniform. Again, why? When uniform, it will cover, the object will cover what? Equal distances in equal interval of time in a given direction. But when I am talking about the non-uniform velocity, there are two cases. What are those cases? The first case is when an object is covering unequal distances in equal interval of time in a given direction, in the same direction basically. So that will be the non-uniform velocity. Again, when an object is covering equal distances in equal interval of time and changing its direction constantly. So that will be also a non-uniform velocity. Okay, so you can see here, when an object covers equal distances in equal time intervals in a given direction, and non-uniform is what? Unequal distances in equal time intervals in a given direction when the direction keeps on changing. These are the 2 points about non-uniform velocity. So this is what is the second concept map. You can take the screenshot of this as well. Okay, so this is what is all about this chapter. So you have to do what? You have to revise the whole chapter. Till then, take care of yourself, keep learning and keep exploring. Thank you so much. Bye-bye.